Hello there, chemistry lovers. Welcome to another exciting journey into the world of chemistry. Have you ever wondered what makes up, well, everything? What are the fundamental components that form the universe around us? The air we breathe, the water we drink, even you and me, they're all made from amazing ingredients called elements. These elements are the building blocks of all matter. Think of elements like the letters of the alphabet. Just as letters combine to form words, elements combine in various ways to create the vast array of substances we encounter every day. Just like letters combine to form words, elements come together to create everything around us. From the simplest compounds to the most complex structures, elements are at the heart of it all. Elements are the simplest forms of matter. Each element is unique and has its own set of properties that distinguish it from others. This means they can't be broken down into anything simpler by ordinary chemical reactions. Pretty cool, right? So next time you look around, remember that everything you see is made up of these incredible building blocks called elements. Stay curious and keep exploring the wonders of science. Now let's meet some of these elemental superstars. The periodic table is like a grand stage where each element has its own unique role to play. There are about 118 known elements, of which 92 are naturally occurring and the rest are artificially made. We've got oxygen, the gas we need to breathe. It's essential for life, allowing our cells to produce energy. Without oxygen, life as we know it wouldn't exist. Then there's hydrogen, the lightest element of all. It's the most abundant element in the universe and a key player in the formation of stars and galaxies. And who could forget carbon, the backbone of life as we know it? Carbon atoms can form long chains and complex structures, making it the foundation of organic chemistry and life itself. Each element has a special name and a symbol, which is like its own secret code. These symbols help scientists communicate complex information quickly and accurately. Symbols are modern ways of representing atoms of elements by using abbreviations. The modern symbols were developed by Berzelius in 1814. The symbol is usually 1 or 2 letters long. First, he used the first letter in the name of the element. Examples are hydrogen with symbol H, boron with symbol B, nitrogen with symbol N, fluorine with symbol F, phosphorus with symbol P, sulfur S, and iodine with symbol I. He also used the first 2 letters of their name. Examples are aluminium as Al, nickel as Ni. Others are helium, lithium, beryllium, neon. Some of these letters come from the element's name in Latin or Greek, adding a historical twist to modern science. For example, gold is Au, silver is Ag, and iron is Fe. These symbols are universally recognized, making them a common language for scientists around the world. Some symbols are a combination of the first letter and another. Examples are magnesium, manganese, zinc. How cool are those symbols? They not only represent the elements but also tell a story of discovery and the quest to understand the building blocks of our universe. But what exactly are elements made of? Get this, they're made up of even tinier particles called atoms. Atoms are incredibly small, like way smaller than a grain of sand. You need a super-duper microscope to see them. Atoms are the basic building blocks of elements. Imagine atoms as tiny Lego bricks. Each element has its own unique type of atom. So, all oxygen atoms are the same and they're different from all hydrogen atoms. Section 4. Molecules, atoms joining forces. Now, atoms love to hang out together. When 2 or more atoms bond, they form a molecule. Think of it like atoms holding hands. Atomicity is the number of atoms in one molecule of an element. Hydrogen gas consists of 2 atoms of hydrogen joined together, so the atomicity of hydrogen is 2, or hydrogen is diatomic. Oxygen, nitrogen, fluorine, chlorine, bromine gases is diatomic. Ozone is triatomic, helium, argon, neon are monoatomic, phosphorus is tetratomic, while sulfur is polyatomic. A molecule can be made up of the same type of atoms like an oxygen molecule, which we breathe, but molecules can also be formed from different types of atoms. Water is a great example. 1 oxygen atom teams up with 2 hydrogen atoms to create the water molecule. Section 5. Metals and nonmetals. A tale of 2 element types. In this chapter we will explore the fascinating world of elements and how they are classified into 2 distinct categories. Elements can be grouped into 2 main categories, metals and nonmetals. This classification helps scientists understand their properties and how they interact with other substances. Metals are usually shiny, good conductors of heat and electricity, and they like to give away electrons. This makes them incredibly useful in a variety of applications, from building materials to electronic devices. Think of metals like copper in electrical wires. Copper's excellent conductivity makes it ideal for transmitting electrical currents efficiently, or gold in your favorite jewelry. Gold's luster and resistance to tarnish make it a popular choice for crafting beautiful and durable pieces. Non-metals, on the other hand, are not as shiny, and they're not so good at conducting heat or electricity. They have their own unique set of properties that make them valuable in different ways. They prefer to accept electrons rather than give them away. This characteristic influences how they bond with other elements and form compounds. Oxygen and carbon are classic examples of nonmetals. Oxygen is essential for respiration in living organisms, while carbon is the backbone of organic chemistry, forming the basis of all known life. Understanding the differences between metals and nonmetals is crucial for scientists and engineers. It allows them to choose the right materials for specific tasks, leading to innovations in technology, medicine, and industry. So next time you look at a periodic table, remember the tale of two element types and how their unique properties shape the world around us. Elements and their states. Some elements occur naturally in solid state. Examples are iron, copper, sodium, potassium. Others occur in gaseous state. Examples are hydrogen, oxygen, nitrogen, chlorine, fluorine, while some occur in liquid state. Examples are mercury, bromine. So there you have it, the amazing world of elements. From the tiniest atom to the vast diversity of elements, it's a universe waiting to be explored. Remember, elements are the building blocks of everything around us, and understanding them helps us understand the world and ourselves a little bit better. Keep asking questions, keep exploring, and stay curious. Thank you for joining us on this journey through the elements. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating science content. See you next time.